welcome to our 7EDU Kids Science Club trail class today. Let's wait for 2 more minutes for more people come in. And the class will start at 3:02.
Sounds good.
So thanks for your understanding and patience.
As a heads up, in a few minutes, probably going to ask for people to turn on cameras. It just helps. I don't like talking to a black screen. So just kind of get ready for it. If you don't have a camera ready, that is okay. I would prefer it though. Thank you. Oh, hello. It's good to see you.
Hey, Max, you bring all your materials?
Yeah.
It's going to be a fun class, huh, Jonathan?
Super excited. It's going to be really fun. We're even going to talk about densities, and we're going to make a little liquid layer thing in a cup. By the way, since we've gotten quite a few people here now, maybe I can. So a lot of these are household items. So I don't know if you can hear me, but a glass is really helpful. If you have honey, perfect. I see you, Sophie. Thank you. Some honey. Most people should have this. Corn syrup may be a little bit harder to find. If you don't have corn syrup, that's okay. Everyone should have dish soap, right? I would kind of hope so, right? That's how we have clean dishes in the house. Perfect. What's next? Okay, a little glass of water. This is just water in a little glass that I have here. Okay, perfect. Vegetable oil. Hopefully we have this. Okay, and I'm not 100% sure if like peanut oil works or any other kind of oil, but vegetable oil, or if you have canola oil, that's really good too. Canola oil also works. And rubbing alcohol. I've got 70% here, but anything 70% or higher of rubbing alcohol works. It smells. This is a pretty strong smell for some of you younger ones, so don't smell it. Perfect. Oh, do we have the same kind?
So
Yes.
if the glass is needed.
I'm sorry, I couldn't quite hear that. Say that again.
If safety glasses needed.
No, I wouldn't say safety glasses are necessary, but they never hurt. If you want to have them on, you can definitely have them on. Question next.
Is olive oil okay?
Is olive oil okay? You know what? I am not 100% sure. I know it works with vegetable oil. You can try it. I mean, that's what science is all about, right? We'll try it and we'll see what happens. Looking good. I see quite a few people have their stuff ready. I'm pleasantly surprised we have all our stuff ready to go. I was a little worried. I was asking you guys to have too much stuff, but it does not seem that way. So I am excited for that.
There's 13 people on this call right now.
There are 13 people in the call right now. So are we including, so there's a few people that are part of 7EDU. There's me, there's 7, anybody who says 7EDU in front, they also, they don't count as students. And our wonderful Jajun is also.
Okay. I think we can start.
Okay. Sounds good. Take it away, Sabrina.
Yes. So next page. Okay, everyone. Hello. So welcome to our Science Kids Club trail classes. And today we are very glad to have teacher Jonathan here to bring us to make a funny experiment together. It's called Layered Liquid Science Experiment. So let me introduce teacher Jonathan first. So Jonathan is Master of Arts in Education, UC Davis, and also got a BS in Psychology and the multiple subjects teaching credential. So teacher Jonathan has taught English, math, science, social studies, and AVID over 5 years in public schools and have intensive experience working with students of diverse backgrounds and their learning needs. So besides teaching core academic content, Jonathan also focuses on motivation and encouragement to help all his students become well-rounded adults who can achieve their full potential. So everyone, let's welcome teacher Jonathan.
Thank you very much for the intro, Sabrina. So, yep, just like you said, before teaching this, I was a public school teacher for 5 years in this place called American Canyon, pretty close to Napa or Vallejo area, if you've heard of it. But that's where I was the last 5 years before I had the chance to come join 7EDU and be a teacher and see all of you here today. All right. So getting right into it, this will be more for your parents to see, just to see what exactly we'll be doing today. So for the agenda, this is more like a breakdown of everything we're going to be learning. So at the very top, you can see science performance expectations. So our expectation for science today is that we're going to make observations and measurements to identify materials, right? We're going to measure something to identify what a material is, right? And that's why we have all these materials here in front of us today. A disciplinary core idea, right? That's the idea within the science discipline of physical science that we're talking about today. That disciplinary core idea is, again, measuring properties to identify materials, right? Properties of materials. Do we have any ideas of what a property of a material is? Do you have an idea of what a property of a material is? Do you have any ideas? How about this? For an example, how hot something is, right? Hot or cold, right? Ice is cold, right? Something feels a certain way, or it smells like something, or it looks different, right? So things that look different, smell different, feel different, they weigh differently in our hands, right? Those things are different properties of things, right? So we're going to measure these to find the difference between properties. So for like example, like the dish soap, right? Notice it's a little bit like watery. It kind of moves in the little container, but the honey doesn't really do that as much, right? That's something called viscosity, right? So that's a big word. It basically just tells you how much of the liquid actually flows when you move it around in a jar, right? So that's an example of a property of something. Okay, next, science and engineering practices. What we're going to do, we're going to be planning and carrying out an investigation to produce data that explains phenomenon, right? So the title of our experiment today was called layered liquids. So you can probably guess that we're going to be layering liquids on top of each other, which is going to be a very strange phenomenon, right? Usually you don't see when you mix your Kool-Aid into your drink, right? You mix it around, it all just becomes one thing. Well, what we're going to see in this glass is that it's not all going to combine. What's going to happen is that they're going to stack, right? And then we're going to produce data to explain that, right? So in science, next, we also have different standards of math, right? Math and science very closely related together. So that means what we're going to be doing is also some calculations, right? So for some parents who are listening, thinking out there, this class was intended for grades 3 to 5. So we're going to be doing some multiplication, a little bit of division, a little bit of comparison, representing and interpreting data, and talking about volume, right? This is definitely very complicated, especially for students, and maybe if you're in grade 1 or maybe in 2nd grade or maybe even in kindergarten, right? So this is something the big kids, right? When you grow older and you get in maybe 3rd, 4th, or 5th grade, this is something you can probably do in class, and it's going to be super fun. And so for now, you're going to just get a preview of things and see what things will be like as you get older. Okay. So with all of that, the agenda done, let's get started performing the experiment. All right. So what I'm going to do is go step by step. So first of all, let's get our glass ready to go, right? If you don't have a glass, if you have any other container, it works best if you can see through it. but you don't have to have the glass. You don't have to have a glass just like mine. We're going to fill it with our different liquids. So number one is honey. Let's grab our honey and let's start pouring it into our glass. Are you ready for it? Let's pour it in. And you don't have to pour in a whole lot, so you can see. I want to pour just enough so that it makes a nice layer, maybe about a 1/2 inch thick at the top, just so you can see that it's really there, you know? So that looks pretty good to me. About a 1/2 inch layer of honey. You can see my layer is there. Actually, let's add a little more. Why not? Let's make it more fun. Let's add more honey in there. Right, and you'll notice in step 2, well, not step 2, well, in part 2, make sure that each liquid settles before you pour the next one, right? That just means make sure it's not kind of all over the place. Make sure it's just sitting in one spot. We have our honey right there as our first layer in our experiment. The next layer we're going to use, right, once it's settled, is called corn syrup, right? Corn syrup. I don't know if you have corn syrup, but if not, it is okay. So what I'm going to do, because you'll notice the corn syrup is a much similar color to the honey, what I'm going to do is I'm going to mix food dye into this corn syrup before I pour it into the glass. So, ooh, look how much look how quickly that flows. The corn syrup, I'm going to pour right in here into a different glass for now. And it's okay if you don't have a different glass. Use corn syrup, and then what I have here is a little bit of food dye, right? This is green food dye. I'm gonna color it. I'm gonna put maybe just 2 drops in there and mix it around, right? So we're changing the way, oh, look at that. We're changing the way the corn syrup looks. You'll notice it's still corn syrup. We're just changing how it looks, right? Once it's nice and green, mixed around, I'm gonna go ahead and now pour the green corn syrup on top of the honey. And let's see what happens. Look at that. Can you see okay? Make sure I get most of it. Don't want to waste any food, right? Technically, you could eat this, and honestly, it probably will taste pretty good. It's honey and it's corn syrup right now. So these are both very edible, very sweet things. And look, can you see now? Can you see that they're not mixing just yet? The corn syrup is on top of the honey, right? Let's move next, right? Once it's settled a little bit, notice that. As we go on, it'll actually separate a little bit more. Let's move to our next item, the dish soap. You ready for dish soap next? Because it's already blue, I'm not gonna color this one with food dye. I'm gonna go ahead and pour it in there and do it slowly. Slowly pour your dish soap on top of the corn syrup to see what we get. Yep, not just dumping it right in. All right, look at that. I don't know if you can really tell based on the screen, but you can see on the bottom is the honey. My middle layer right now is my corn syrup, and my top layer is dish soap. You can see the yellow to the green to the blue, right? Next, let's add water, right? Everyone should have some water to add on top. So if you so far have not had all the things that I've had, that is okay. They'll still stack on each other, right? So this time I'm going to get water and I'm going to use red food dye for this water. You don't have to dye yours. It actually doesn't change much. It just makes it look a little bit cooler. That is okay if you don't have it. I added 3 drops of red food dye. Go in, give it a little mix. And we can see that it's now red, right? Now let's pour our red water on top of our dish soap now. You ready? Slowly. Try not to make a mess. Notice it's being poured and it's happening right on top. It's not mixing right in. Look, it's red water. Notice it's kind of bubbly right now. And obviously, it's because the water is mixing with the dish soap, right? And that's okay. Not a big deal. We're just going to wait till it settles for a little bit, right? So the water's been colored red, and it's on top of the dish soap. And now taking a look, see at our bottom, honey. The green is the corn syrup. That blue is the dish soap, and the red is the water. Nice. Who has theirs so far? Can I see? Hanrui, do you have yours? Wow, that's so nice. Look, yours is all stacked up. Max, wow, look, I see his is all stacked up too. He's got 3 different colors. So it looks like maple syrup did work. How about Talia and Vienna and Carson? Oh, nice. So you've had your honey and your water too, right? Perfect. And so later on, I know this was kind of last minute, right? And we did ask you guys to have a lot of stuff. You can always request a recording, and then you can get all these materials that I had, and we can go through and we can or you can go through at home and watch what I'm doing, and you can see it even better. All right, the next one is vegetable oil. Now you'll notice I'm not coloring the vegetable oil. It's because food dye and oil actually don't mix. If you try in the future, you'll see that too. Food dye and oil do not mix. So what I'm gonna do, I'm pouring my vegetable oil on top. Be very, very careful if you have this too, right? Oil is very greasy. And your parents will probably not be happy if you were to spill any on your table. Pour very slowly on top. Following along with me. So far, I just made the water a little cloudy, but wait a minute. You'll start seeing it separate pretty soon. Let's leave it at that for now because it's a little bubbly, and that's okay. Let's do our last layer, rubbing alcohol, right? I'm gonna prep it now before you get started, right? I'm gonna prep the rubbing alcohol. I'm gonna pour it into 1 more glass, and I'm gonna color it blue. I'm gonna pour my rubbing alcohol right in here. And I'm going to color it blue. My blue, I don't know if you can see, blue food dye goes right in. Give it a little mixy mix. Oh, it looks like our dish soap, huh? Maybe a little bit bluer than the dish soap. But it's a nice dark blue. A nice mix. Ah, look, I'm seeing it. Do you see that layer? It's kind of a bubbly layer of vegetable oil right now. But as it settles, it's going to get less and less bubbly. All right. Let's pour our rubbing alcohol on top now. Careful. Let's just use up the rest of it. It's a little muddy right now, but watch what's going to happen. They'll separate soon. All right, look at our liquid layers at our bottom. We have our honey, then our corn syrup, our green corn syrup, our blue dish soap. Might be a little muddy right now, but the red you can see on top, that's our water. There's a little clearer layer of vegetable oil here. And at the top is our rubbing alcohol. So cool. I love it. All right. So at this point, yep, all our liquids have been mixed. We're seeing a nice clear layer on top. Let's go and take a look at what this science is behind it. Now, I'm going to ask you all a couple of questions. I hope you're going to be okay looking at it with me. Okay? Yeah, let's take a look. Let's read the first one together. It says questions and reflection, part 1 of 2. It says the density of a liquid is a measure of how heavy it is for the amount measured. If you weigh equal amounts or volumes of two different liquids, the liquid that weighs more is more dense. Does anyone have an idea? So question 1, based on this reading above, what is density in your own words?
I know,
Yes?
I know how I know why it's layered.
How heavy it is.
So
How heavy it is.
I know,
Oh,
I know how it's layered because honey is the most dense and alcohol, alcohol the least dense. That's why alcohol sits on top and honey sits on top.
that is true. Thank you, Hanroy, and thank you, Eric. Does anyone else have anything they want to add? Yeah, Max, thank you for raising your hand.
I think I know what it is, but to say it in my own words,
Yeah.
it's the weight of it divided by the size of it.
Yeah, actually, that's a really good explanation there, Max. Thank you. So thank you, Hanroy. Thank you, Eric. Thank you, Max. Does anyone else have anything they want to add about what they think density is? Right? Y'all have really great ideas so far, and you feel free to share anything you want to share. But let's start adding in our ideas. So I'm going to put in our words just so you can see what we're doing. So I think I heard from Eric and Hanroy that density is how heavy something is. Is that right? Is there anything else you wanted to add for that? Density is how heavy something is? How heavy, or something. How heavy a liquid is. And would you mind repeating what you said again?
Pour this thing away now.
Say again?
Can't pour the liquid away now because can't pour the liquid away.
How about, okay, hold on a minute, keep it there in front of you because it's going to look cooler as it separates later on. And I'll tell you how to dispose of it.
It already separated.
Okay. I want to go over and tell everybody how to throw it away because there is oil in there. You don't want to pour that down the sink. So just look on with me right now for the reflection questions, and then we'll go over that. Okay. Thank you very much. Sorry, Max. Would you mind saying one more time what you thought density was, or what you knew density to be?
Density is the weight divided by its size.
Density, yeah, is weight divided by size, right? We'll talk about size of a liquid, how big a liquid is, right? Amounts or volumes. That's how you measure a liquid, right? If you have a big water bottle, you can say it has more volume. If you have a little water bottle, you say it has a little volume, right? So for example, bigger volume, little volume, right? The size of the liquid, right? Okay. With that, let's take a look at a little animation too to answer these actually 3 questions below. So like Max was saying too, you saw that different densities of liquids. Oh, or maybe it was Eric who mentioned that too. It was like, oh, honey is the most dense, right? And the rubbing alcohol is the least dense. Let's take a look at that. Density of liquids. Play a little, let's play a little thing of it. Put the same amount of water and corn syrup in identical cups, right? So in this example, there's water and then there's corn syrup, colored blue, right? if you were to put them on a scale, right, the corn syrup would be heavier because it weighs the scale down, right? The corn syrup weighs more than the water when there's the same amount of it, right? When there's the same amount of water and corn syrup, let's see, the corn syrup would be heavier and it would go down on the scale. So since corn syrup is more dense than water, right, the corn syrup sinks and the water goes to the top, right? Because it's more dense, the water can stay on top of corn syrup, right? It can stand on top, like a human pyramid, right? I don't know if you've ever been in one before, but people on the bottom, right? Usually one of the heaviest people on the bottom of the human pyramid. And you want the people that are lightest on top of them, right? So they stand on top, they're going to be lighter, and so they'll float on top, just like stacking the liquids, like stacking people, like stacking boxes, right? You want lighter boxes on top of heavier boxes, because that way they'll be stable. Let's look at the next one. Now, looking at this, putting the same amount of water and vegetable oil in identical cups, right? Let's see what happens when we put that on a scale. When you put vegetable oil in water, the water weighs more, right? It's more dense than the vegetable oil. So the water is going to be weighted down and the vegetable oil will go up. And if you've ever been on a seesaw, right? When you're when you're a little kid, you go on the seesaw up and down like that. Very similar to that too. But when you're on a seesaw, obviously you're kind of jumping, so you're adding and kind of taking away weight as you put more force on it. But that's something for another time, right? So just think about it like a seesaw. The heavier side gets lower, the lighter side goes to the top. So since vegetable oil is less dense than water, the oil floats on top of it, right? The oil will float on top of the water. So what happens if you were to pour corn syrup into oil and water? Before I play next, let's have someone try to take a guess. I want to try somebody. Like, thank you, Hanro, thank you, Eric, and thank you, Max. I really appreciate. And I know you guys probably know.
I think it's the corn syrup.
What do you think is going to happen with the corn syrup, Eric?
It's gonna sink down.
You think the corn syrup is going to sink down? Does anyone else have any other ideas, or does anyone else agree with that? What do you think, Max?
I think it'll mix.
You think it'll mix? Yeah, that's a good guess too. How about anyone else? We have a lot of shy people today, but that's understandable because it's just our first time. It's probably your first time seeing me. First time seeing all these other people. Does anyone else have any ideas what's going to happen? Give you maybe a couple seconds to think about it. How about this? If you don't want to share, think about in your head what's going to happen. Is the corn syrup going to sink? Is it going to go to the top? Is it going to mix? Let's play and see. See, the corn syrup goes to the bottom, right? Oil is the least dense, so it floats to the top. Water in between has a density, right? In between. And then the corn syrup is on the bottom, so it's the most dense, so it sinks down to the bottom, right? Okay, with that, I'm going to close. So let's do a little quiz for you guys, right? Hopefully not too hard, but let's do a little quiz. Let's look at question 2. If you filled 1 cup with water and another cup with corn syrup, which cup would be heavier and why? If you filled 1 cup with water and 1 cup with corn syrup, take a look at my cup too, by the way. Take a look over here. I know it's a little cloudy.
I think the corn syrup would be heavier. Why? Because it's the most dense.
Right. Thank you, Eric. I appreciate that. Yeah. If you fill the cup with water and corn syrup, right? Like we saw in our experiment, look, the green corn syrup, right, is on the bottom, and I know it's still a little hard to see, but our red water is over here. And so the water is less dense, right? So like Eric said, I'll change my color to red. The cup with the corn syrup would be heavier because it is more dense, right? It weighs more for the same amount, right? Let's look at another one. If you filled 1 cup with honey and another cup with dish soap, which cup would be lighter and why? Right? And before you speak, thank you very much. I want to give someone else a chance. Hey, Sophie, how are you doing over there? I see you turning your camera on and off. Do you want to tell me which cup would be lighter, honey or dish soap?
I think dish soap would be
Mhm.
lighter.
Mm-hmm. Why do you think dish soap would be lighter? Think about that word we've been talking about, density, right? Is it more or less? Ooh, more dense means it's heavier, right? So take a look. Our honey is here on the bottom, and our dish soap is blue over here. So thank you for that. Yeah, Sophie. So the honey actually, yeah, that's what you were saying. The honey is more dense than the dish soap. And thinking opposite ways, right? Thinking opposites, the dish soap is less dense than the honey. So what we can say, like Sophie was saying, um, the cup filled with dish soap would be lighter because dish soap is less dense than honey, right? And we can see that right here, right? Our yellow honey on the bottom and our blue dish soap above the green corn syrup, right? We can see the difference there, right? Let's look at one more question here. And you guys are doing a really, really great job. I'm really proud of you guys. Because I know this is pretty tough stuff. And most of you seem young. Maybe you just look young. Maybe I'm old and you look young. But anyway, how about, if you feel comfortable, can I ask Talia or Yelena or Carson? Look at this question over here. Imagine a cup of rubbing alcohol on one end of a scale and a cup of vegetable oil on the other end. What would that scale look like? Which one would be lower? Which one would be higher? Can one of you want to take a guess? Think about the order that we poured stuff in, right? The rubbing alcohol, I'll give you a hint. The rubbing alcohol we poured last, right?
Don't. Yes.
Yeah, right. So if the rubbing alcohol we poured last, what do you think? Well, what would that scale look like? Which is heavier?
I think the oil will be heavier.
The oil would be heavier than the rubbing alcohol, right? So does the oil go down or does it go up?
Goes down.
It goes down. Perfect. Is that you, Carl? Thank you very much for sharing that. Very nice job. And thank you. I see everyone else is looking too. I see them. Yeah, there. You're nodding your heads. I see what you mean. Yeah, exactly. The oil is more dense than the rubbing alcohol. So it would be down on the scale, right? The oil is more dense than the rubbing alcohol. So it would move down on the scale. Okay, so that's our first part of our questions. Now this part can look a little intimidating, but I do want to talk about it a little bit for my students who are a little bit older and who might want a little bit of a challenge. So if you don't get it, don't worry, but I do want to go over and hopefully someone can help me with this. So questions and reflection part 2 of 2, looking at this one. The formula, ooh, it's a big word, right? Formula to calculate the density of a liquid is D equals M divided by V. D is density, M is mass, the amount of matter in an object, and V is volume, or the amount of space taken up by an object. You can calculate density by dividing mass by volume. And I had a feeling Max had an idea of this. He was even mentioning that earlier, kind of doing a little sneak preview of what we were talking about. He was saying, yeah, density, right, is the mass or the amount of matter in something divided by its volume, or how much of it is there, right? So if I can divide mass by volume, I'll get the density, right? So looking at this table, mass is measured in something called grams, and volume is measured in milliliters, right? Grams and milliliters. Density is mass divided by volume, or 20 divided by 5. Wait, but, so what do you think density would be for corn syrup? So for corn syrup, 20 divided by 5. What do you think that is, Hanwei?
I think it's 4.
You think it's 4? Yeah? What do you think, Ryan? I see you raising your hand too. Oh, you're muted. I can't quite hear you. Can you unmute? Or did you not want to share? I just saw you turn your camera on. So I thought you might want to share. You're holding it up. Do I see 4? Yep, 4, just like Hanwei said and just like Ryan said. The density of this corn syrup, when there's 5 milliliters of it and it's 20 grams, let me change my color so you can see, very nice job. It's 4 grams per milliliter, right? 4 grams per milliliter. Let's look at the next one underneath. You're doing an awesome job, everyone, by the way. Dish soap. Let's say I have 15 grams of dish soap. That takes up 5 milliliters of volume. You want to hold up, maybe you can hold up fingers, or if you want to share, what do we think is the density of this dish soap? If dense,
I think it's 3 a gram or a milliliter.
3 grams per milliliter. Can you explain, Eric, why is it 3 grams per milliliter?
Because 15 divided by 5 equals 3.
That's exactly right, Eric. Very nice job. And for those of us who might not know division just yet, think about it. If there's 1 5, right? Here's 1. Here's 2 5s, right? That makes 10. Add 1 more 5, and that makes 15, right? So 5, 5, 5 makes 15, right? So 3 5s make 15. So our density here would be 3 grams per milliliter because there are 3 5s in a 15. Now, this is a little bit more of a challenging one here. Let's look at this next one. This time for water, we're given mass is 5 grams. We don't know the volume, but we know the density is 1 gram per milliliter. Do we have an idea of what this could be?
5?
5? Is that you, Sophie? Did you say 5?
5.
Yeah. Were you going to say 5 too, Hanwei? What are you going to say?
Wait, no, I said 5.
5. Yeah, 5.
Eric Han also says 5. Very nice. I'm saying Hanwei.
For vegetable oil, it is
1.
Oh, here, let me move on from there. Oh, before we move on ahead, thank you very much. Yeah, exactly. So density is 1 gram per milliliter, right? And so if we were to do grams, right, the mass on top divided by the volume on the bottom, V, I wonder if I want to do something fancy, and I want to share something, but I don't know if I want to be able to annotate, right? Okay, perfect. So my density is 1, right, equals our mass on top, 5, over our unknown number volume on the bottom, right? And we should know any number divided by itself is 1, right? So that's grams, G, 5 milliliters, L, is 1 gram per milliliter. Density. Thank you sorry about that. So let me stop doing that. How do I do that? X out. Okay, so let me type that in now. This one.
So can I explain how you do vegetable oil?
You want to do the vegetable oil? Yeah, Hanwei, take it away.
So you see, it's 0.8 grams per liter.
Yes.
And the 5 liters.
Yes.
then you do 5 times, so then you do 5 times 0.8.
You would do that, exactly. What would that number be? Do you know?
So the way you do it is just,
Uh-huh.
so the way you do it is you just keep on adding 0.8 until you
You
get
could
to,
do that.
so then it'll be, so then it will be 5, it'll be 6, maybe 6 point, 6 point, let's see, it'll be 6 point something. It'll be
Want to
6
do
point, what's 0.2, 0.2 out of 0.8, 0.2 out of 0.8 is 6 point.
Ooh. Hey, thank you, Hanwei. You got us started. You got us started pretty well. At one point, what you want to do instead of adding 0.8 to get to 5, you want to add 0.8 to itself 5 times, right? So I know for some of you this could be very confusing, right? Well, what I'm going to show you is when you add 0.8 5 times, and as much as I'd like to go over that with you guys, I believe we're kind of running a little short on time, but let me do a quick annotation for you. So our density, so let's, how do I clear this? Clear it. Let me get rid of all this stuff. So our density here is 0.8 equals our mass on top, our unknown m mass on top, times our volume, sorry, not times, divided by, I'm sorry about that, our volume 5 on the bottom. So what you want to do, like Hanroi was saying, you want to multiply by 5 on each side, right, to cancel that out. Multiply by 5. And if you had a calculator or if you were able to add 0.85 times, what you'll find is that it's actually 4. It's going to be 4 grams. 4 grams, right? 4 divided by 5, right, is less than 1. So that's 0.8. Very nice. I know that's very confusing. And I saw that a lot of you were very young, but you all did a really, really awesome job, right? Thank you very much. What I want to do next is just go over our last thing for today. Let me just get rid of all this stuff and go on to our very last slide. Present. So with that, if Sabrina or Jajun or anybody else wants to jump in, what we have today, I really hope you guys enjoyed it. Oh yeah, by the way, for disposing of this, by the way, what you can do is pour the rubbing alcohol, everything except the oil, you can pour down the sink, right? What I would probably recommend you do is to get like a sealed bag, pour it all into the seal bag, like a big Ziploc bag, right? Because you don't want to pour oil down the sink. What's going to happen is going to clog up your sinks and your parents are not going to be happy. You want to grab your liquid, pour it into a bag or any kind of container, any like plastic container, and just throw it away, right? Your parents can clean the glass for you. Does that make sense to everybody? Do not pour this stuff down the sink. It's not going to be good for your pipes, okay? Thank you very much for that. Pour it, yeah, ideally a sealed bag or, you know, a plastic to-go container. If you ever get like soups or anything like that, pour it into a soup container, throw it in the garbage. Yeah, I would not recommend pouring this down the sink. Okay, with that, I hope you all really enjoyed our science lesson today. If you're interested, starting next Saturday, I believe we're going to be really going into it, talking about more fun experiments with water. And we also have our 7EDU Kids Fun Club coming up. That's our Christmas Kids Adventure. It's more for grades kindergarten to grade 3. And we also have this online event from December 9th and December 16th, a parent-child interactive special program. If you're interested, this is the email for it. And I believe that's all the time I have. Sabrina, Ryan, Jajin, do you have anything you want to add?
Okay, thank you very much.
Thank you.
So kids, do you have any other questions about it? Feel free to ask Teacher Jonathan.
I'll be here for a little while. Any questions you want to ask me?
If we don't have
Mhm.
any questions, can we leave the meeting?
Only if Miss Sabrina
Yeah.
says so. Uh-huh.
Yes.
Okay. Thank you very much. I hope you really enjoyed it. If you want to see more, starting next Saturday, we'll have it. Okay. Thank you very much, everybody. Bye now.
Yeah. Bye.
Wow, super cool. I like that one. I like your stuff. Bye bye.
Thank you. Bye bye.
Thank you. Bye bye. Remember,
Thanks,
don't pour your
bye.
stuff down the drink. Thank you. Bye bye. All right. Oh, I'll go ahead and end the meeting now, unless you guys want to say anything. Bye.